This is easily the largest 3D printer that I have ever worked with. I'm 6 feet tall and this thing is enormous. I'm talking about the Elegoo OrangeStorm Giga that launched over on Kickstarter last November. And today I'm going to be giving you an overview of this 3D printer, as well as showing you a couple of huge things that I printed with it so far. This printer is so large that I don't even know how to set up my camera to capture the printer and me in it. It's just, it's a whole nother level of working and recording videos with a printer of this size. Yeah, you are definitely, if you're getting one of these, if you back this on Kickstarter, first of all, I think you're really gonna enjoy it. I've had a couple challenges with it that I'll get into, but once I've got everything leveled and going, this printer has just been running basically non-stop, and I'm loving the ability to print with just some enormous things. Now, it is gonna eat a ton of filament, so make sure you have a bunch on hand. Now, Elegoo did send this printer to me, as well as a handful of other content creators to make content with and show off, as well as provide feedback directly back to Elegoo. And hopefully, some of the things that I'm calling out in this video that I've already relayed back to Elegoo can be adjusted, mostly firmware related, before any of the Kickstarter backers receive their units. Also, please do not consider this a review of this 3D printer. I'm heavily sponsored by Elegoo, and in fact, this video is also sponsored by Elegoo, and in no way is this should be considered a review. However, I will be providing my direct feedback that I provided to Elegoo directly to you as well, just for full transparency. So how big is the build volume on this huge 3D printer? It is 800 by 800 by 1000 millimeters high. That is significantly larger than any other 3D printer I have. It also has 4 large segmented beds, independent PEI sheet, magnetic sheet beds that are the exact same bed size that you're gonna find on the Neptune 4 Max. So essentially, we're taking 4 of the Elegoo Neptune 4 Maxes and mashing them up against each other to make this ginormous 3D printer. And I've had this for a little over a week now, and I did a live stream unboxing that took quite a while to get up and running and set up. And I have to say, it is definitely a 2-man job. Do not do this by yourself. You'll potentially end up dropping something like I did, or screwing something else up along the way, like I also did during the live stream, during that very long live stream. But this thing is extremely rigid and well built. I mean, it's gotta be for a printer of this size, and it is extremely heavy. It comes in 2 huge boxes as well, so you're gonna have a fun time getting that into your house or apartment or wherever it is that you might live. And speaking of, you definitely need a good amount of space for this printer, not only just for the machine, but you also need to be able to access potentially the side and the back side of the printer to get access to things like the on-off switch, the power plug, as well as the filament that runs from the back of the machine. One of the other immediate things that I noticed with this printer is this huge touch screen. So it's massively larger. This is a 7-inch touch screen, significantly larger than any of the other Neptune 3D printers that Elegoo's produced, or basically any other 3D printer that I've worked with. It's basically a large tablet. However, it is tethered to the machine. However, that cord is long enough that you're able to access any area of the printer with this display. So if you're behind the machine working on that far back corner of the bed, you're still able to get the tablet all the way over there. There's also a little hook on the back is how it attaches to the frame here as well. The printer's also running Clipper, which means you have a lot of controls and options when it comes to how exactly you want this printer set up and running. And it also has Wi-Fi built into it. So that means that you can slice files directly from your PC and wirelessly transfer them to the printer. Now, keep in mind, one thing that I immediately noticed with this is because you have such large prints that you're going to be slicing and printing, your G-code files that the printer reads from are going to be drastically larger than your typical G-code files. So in one case, I had one that was over 500 megabytes, and it was taking, I don't know, anywhere between 5 to 10 minutes for that file to transfer. So in some cases, depending on the file size, it's definitely gonna be faster for you to save that to the SD card and insert it, which, by the way, the SD card is directly on the bottom front of the printer. I'm not a huge fan of that location. I would have preferred it honestly up top or directly in the tablet. It is what it is. I'm gonna end up ordering ordering a low profile USB, so I'm not potentially gonna kick it or knock it loose. Next to the USB on the front, you also have an emergency stop function. So if you needed to completely stop all of the motors of the printer, you can press that button. There's also another USB behind the frame there, which I'm assuming is for powering up the USB cameras that they offered during the Kickstarter campaign. This is also a direct drive extruder. It's a different design than we've seen for a lot of the other Neptune 3D printers. It is feeding the filament directly from the top. There's no PTFE tube leading into that from the very top back of where the filament is mounted on the back. So you can mount either that small spool holder or your regular spool on the back, that 1 kilogram roll, or they also have this heavy duty spool roller that you can put in the back that'll allow you to put on 3 kilogram or up to 5 kilogram rolls of filament to feed directly into the printer. Also, unlike a lot of the other Elegoo printers, this one comes stock installed with a 0.6 millimeter nozzle. Thank you. It also comes with extra nozzles. There's a 0.4, a 0.6, a 0.8, and a 1.0 millimeter size nozzle. And since there are 4 print beds, they're actually 4 independently heated and leveled print beds. So you have the ability to control which one is heating up or printing depending on where your print is positioned. And if you wanted to, you can go in and disable particular print beds if you're not using those. Now the Giga does have auto mesh bed leveling. However, it also has manual bed leveling included with it, which is one of the tricky points that I wanted to talk about. I easily spent the bulk of my time when I first got this assembled. I probably spent the better part of a day just trying to get that leveled properly, or what I felt like would be properly leveled for this to be printing. And then even then, after getting it printing, it still wasn't level enough, and I had to go back through the process again. And that process involves you removing the 2 front build plates and then putting down this specially included build plate that has holes in it so that you have direct access to the bolts that are in the bed. This is going to allow you to individually adjust each point on the bed. Thankfully, there is a calibration tool directly built into the printer that's going to go around, measure the values, and then you can go back through and try and get those as close to 0 as you can. So tightening or loosening and then rereading the value to get it as close to 0. Unfortunately, one of the firmware issues that I've reported back to Elegoo, and it's probably the biggest issue that I've had so far, is that I'm not sure how accurate it is, because one thing that I found is when I measured the bed and then went back through and decided to just let's go back through each of the points and not adjust anything, the values kept incrementally changing. So to me, that means something wasn't quite right in the firmware. I've already provided that big amount of feedback back to Elegoo. However, one thing that worked extremely well for me was basically I went through, manually leveled the bed, got it to as close to 0 as possible, then went and did it again to get it dry and get it back to close to 0, and then went through the auto mesh bed leveling calibration and then adjusted the Z offset. Now, one other thing that I also did that you can freely download off of printables is I have a bed leveling test for the printer that I designed. It takes about 12 minutes to run if you want to run the full thing. You don't even need to run the full thing, but this is allowing me to go through and test that and see how level the bed is and readjust the Z offset while I'm printing that. Another fun thing with this is that the Z offset wasn't entirely sticking every time that I went through and did a print. Normally, when you run a print, change the Z offset, it saves back to the printer. And unfortunately, I have to keep adjusting that, or so it seems. Also, I know there was a lot of concern online about the 4 beds and having them interconnected and not, having that seam in between them. I would say if you're planning on printing something flat for display purposes, and that flat side is the front-facing display, then yeah, that it's probably a valid concern. You're gonna see a little bit of a seam there. However, I've gotten these beds so very close together that it's extremely minimal and not showing up as much as what I initially had it with when I first had the printer set up. And it's, at this point, I'm almost afraid. I don't even wanna touch anything. I've got everything leveled so well and those beds precisely placed that it's like I'm very carefully trying to move move and get things off of the printer. Also, when it comes to actually slicing your files for this, Elegoo is providing a version of Elegoo Cura, which I went online and complained that, hey, that's great that you guys are doing this, but can we please get a newer version of this? Not one that's I think 3 years old at this point, or maybe even 4 years old at this point. So they are actually working on that. I know for a fact that they're working on that. And Elegoo's also working on some Orca Slicer profiles for the Giga, which I'm extremely excited about. I ended up creating my own Orca Slicer profile for this, which is what I've used for all the different prints that I'm printing so far with it, and I'll be sharing that with my Patreon. However, I also have a free version of that profile that I'm going to be sharing over on Printables. By the way, if you're interested in seeing exactly what are the dimensions of the printer, this is 1,225.5 millimeters wide by 1,102 millimeters deep, and it's 1,359 millimeters tall, not including the tablet display or the spool holder in the back. When it comes to actually preheating the extruder and the 4 beds, it took the extruder about 1 minute to get over 200 degrees. For the 4 beds, it took almost 7 minutes for those to fully heat up to 60 degrees. Not bad. Also, I did capture a decibel reading just to see how loud the printer is when running. I would say the loudest noise is coming from the actual extruder, the motors there. The fan isn't too overly loud while it's printing or anything like that. Also, obviously, the further you move away from the printer, the less noise you're going to hear from it. I even went as far as going in the next room, which doesn't have a door on it, but it's directly next to this room, and it was significantly quieter. Now, this printer has the capability of running 4 print heads. They're not independent print heads. They are going to print the exact same object just in 4 different quadrants of the printer. So this will allow you to either work with the same material or different colors of the same material and print the exact same object or set of objects multiple times on one huge print bed. And to account for that, there is on the back wiring set up in place for extra filament runout sensors and areas for you to mount those additional spool holders to the top of the printer. Now, one thing that I'm not a huge fan of is the spool holders all the way in the back of the printer. That means that wherever you set this up, you need to be able to get to the back of the printer because it is way too long to reach over and mount the spool holder from the front. It would have been ideal for me to have those directly on the front of the machine so that I could just be directly in the front of the machine and then manage all the filament going in and it's feeding in just in the opposite area. The same thing goes with the large spool roller that you're going to sit on the ground or somewhere behind the printer. And when you want to use that, if you're just using the single head like I am, you unplug this filament runout sensor and plug it into this other one that's going to help feed the filament from down below over the top frame here directly into the printer. Now, I have to say, I was initially nervous about the filament running so far down into the direct drive extruder and maybe potentially it rubbing up against something. I've had 0 issues with the feeding of the filament from the top back or from the ground all the way up through this spool feeder into the direct drive extruder. The direct drive extruder also had 0 issues pulling the absolutely huge Texas-sized spool of filament from Ziltech. This is just a massive 5 kilogram spool of PLA that I used for one of my prints. I also really enjoy this large touchscreen control. Maybe it's because I'm getting older and have trouble precisely hitting things. The buttons are so much bigger on this. I know I'm sounding really old, but it's just really easy to interact with. I can independently adjust each bed temperature if I need to. If I had multi-extruders, I could individually adjust each temperature of each extruder. There is a adaptive speed setting that I can enable or disable with this. I can obviously adjust the Z offset as well as the print speed and the extrusion flow rate. One thing that is missing from this interface here is the ability to control if the filament runout sensor is running or not mid-print. So I would like to see that get added back in here like the other Neptune 3D printers. But when you're not printing, the main settings options for the printer have a lot of different calibration options, including vibration compensation and PID tuning. One thing I wanted to call out that I immediately noticed when doing the live stream unboxing is just how short the power cable is. And unfortunately, this just isn't your standard power brick cable that you find with most other 3D printers. This is a specialty designed option. However, you can find longer versions of this available over on Amazon. I ended up ordering a 10-foot long one to reach the outlet on the other side of the printer. The problem is this is so short that it barely spans the width of the printer. So if your outlet is on the opposite side of where this is plugged in, you're definitely gonna need another cable. And when it comes to the pricing of the Giga, the Kickstarter campaign for the Giga was $1,500. So that was the pre-production backing pricing to help fund to get this thing made. Now, when it's actually made available online for purchase directly from Elegoo, I don't know what the pricing is going to be. They have listed on the Kickstarter campaign $2,500. Maybe it's $2,000. I honestly don't know, or even when that will potentially happen, because they have a ton of Kickstarter backed orders that they need to get through. And the very first thing that I printed was this pre-sliced Buddha file that came preloaded on the printer, and I think it took about 2 hours, a little over 2 hours to print. And I forgot to also mention that the printer came with a full 1 kilogram roll of Elegoo PLA, which I ended up using for this white PLA for the print. And it looks really clean with that 0.6 nozzle, and I'm assuming this is at like a 0.2 layer height. I honestly don't know. I then wanted to try and print something that was almost the entire size of those 4 build plates. So I found this amazing Dune print available over on Printables. And unfortunately, the very first attempt at it completely failed. I think what ended up happening was my print ended up lifting in some parts on the print bed because it wasn't level enough. I don't know if it was the leveling or the Z offset, or maybe a combination of both of those. And this print ended up catching itself and shifting ever so slightly and just causing a huge mess. And I ended up canceling the print before it was fully finished. Obviously, it just, yeah, was not fun. So with big printers come big print fails. But after rerunning my bed leveling tests and reprinting this, it turned out so good, and it is huge. It is absolutely enormous. I almost just want to keep it as is, all connected, and leave it up on the wall. This looks like such an epic little DIY kit, a little Gundam style kit that would just be an awesome art piece. This was scaled up by 300% of the original size as well. It's just massive. And then I brought it home and got it all assembled to show you here. It definitely took a little while to get everything put together. And one thing I didn't think about, which I should have realized, is some files are not designed to be printed at this large of a scale. The wings weigh so much that everything is just sort of tilting backwards and having a hard time balancing here when sitting it flat. But I think if I just open up the wings like they are designed to be, just completely wide open, it should help balance itself out and allow it to more easily balance here. Yeah, there we go. That actually is sustaining itself, and it is just huge. Again, another really cool piece of art or toy. Again, I print lots of these types of things. This is like my jam right here. So you'll be definitely seeing more huge, goofy, fun prints like this on the channel here. I then wanted to test out printing something just absolutely insane and larger than basically I could fit on any other 3D printer. And I ended up finding this file from the Galactic Armory, which is a life-sized Rancor Head that unfortunately was even too big for this printer, so I scaled it down to fit the print bed, which was about 50% of the original file size, and went and sliced it and got it printing. Now, this wasn't without another set of challenges, which I didn't realize. I sliced this using Orca Slicer using their Make Overhangs printable to help dramatically reduce the amount of supports that we're gonna need, as well as cut down on the print time. However, it still required a handful of supports, and what I didn't realize was that there was one huge section being supported by 2 really small supports. And unfortunately, those supports failed mid-print, so I had to get creative. And I ended up breaking out the hot glue gun and hot gluing cardboard and tape and extra Neptune print beds directly to the cardboard and stabilizing where it was failing, and got the print to actually print directly on those print beds and saved the whole area that I was printing. I was in shock that that actually worked. No fault of the printer whatsoever. That was all user error and not realizing that after I sliced the file. And one other call out about slicing large files, not only are the file sizes drastically larger, but I was also having a hard time getting the slicer to play back the preview of that sliced file. Everything was extremely laggy in Orca Slicer with those huge sliced files. And after a little over 3.5 days of printing and about 3 kilograms of PLA, this massive print finished. And it looks so friggin' amazing. This is exactly what I envisioned this printer being printed things for. Like just enormous one-piece display pieces that I can now put up here in my studio. And while that head was printing, I also printed the tongue as well as the teeth over on the Neptune 4 and the Neptune 4 Plus 3D printers. And just for making a full rounded experience, I also printed that tongue all in resin on the Elegoo Jupiter SE. And since I'm planning on painting and finishing this, I ended up using my hot glue gun once again to glue all the teeth and tongues in place. And check out the finished piece. This is so cool. I am so utterly happy with how this print turned out. Honestly, this printer, with its handful of issues that I've called out, still the big factor with this is being able to print amazing large things like this. I am so excited to have this printer on hand and be able to design and print some stupidly large things on it and show them off to you guys. This is gonna be so much fun playing around with this 3D printer. This again took a little over 3 days, about 3 kilograms of filament. I don't entirely know how much it took, but it just turned out amazing. And then the opening where it failed, I just ended up re-slicing that one part and reprinting it. What worked out really well is also, you can see here how this is just entirely hollow, but you can see where Orca Slicer, instead of using supports, printed everything at an angled infill. But here is where that failed, and all I did was print it, and I ended up printing it too large, but that actually worked out great. It just works as almost like a cap, where it caps off that opening. And then once the tongue is installed, you don't even see it whatsoever. It's hidden entirely. Now, obviously the Rancor needs a bone, so I found a bone online, a femur, and am able to jam this inside of the mouth as well. Also, I don't think this is gonna work, but I wanted to see if I could try to weigh this print. All right, I got it. It weighs 9 pounds, 6 ounces. And since I'm planning on painting and finishing this, I will be using that resin tongue that has all that fine detail just to show off how gory good this can potentially be. Also, I'm pretty impressed. This was all printed with that 0.6 nozzle at a 0.32 layer height. Now, for some of the other things, I'll probably end up printing at a 0.2 or 0.28, depending on what I'm printing. But for most of these really large prints, I'll be printing with a 0.32 or potentially even higher. And I am really looking forward to trying out some of those larger nozzles, especially the 1.0 nozzle size there, and printing some really large pieces of furniture or just some crazy large objects. But let me know in the comments what you think I should potentially print next with this. And if you didn't already see, I actually have one print running right now that a lot of you have been asking for updates on. Now, I also want to say a big thank you to all my Patreon supporters for your continued support of me making content like these here on the interwebs. If you're interested in my 3D printer settings, like the Giga profile that I created for Orca Slicer, you'll find those over in my Patreon. And I'm really excited for all of the folks that ended up backing this project over on Kickstarter and seeing all of the crazy big things that you all end up printing with it. And hopefully Elegoo will make some adjustments that are needed to the firmware that I've called out, as well as some issues that potentially other creators that are making videos on this as well have brought out. Hey, thanks so much for watching, y'all, and I'll see you next time. Bye now. Oh, that thing's heavy. By the way, I was told this it makes much more sense. I initially thought this was like supposed to be designed after a grasshopper. No, it's not. It's designed after a dragonfly. Makes totally so much more sense. I don't know what I was thinking.